In this video, I'm going to be working practice problem for test 8 for AP Pre-Cal, which is going to be all about solving trig equations. And this first one here says we can use a calculator, but I don't think we're going to need to, and I think we can, solve this without one and use the tools that we've been working on lately. So they're telling us f of theta is sine theta and g of theta is sine of theta plus pi over 2. I also know on the interval 0 to 2 pi how many solutions exist to f of theta equals g of theta. Well, what I'm going to do is I'm just going to use the angle addition formula for sine. Right, sine of a plus b equals sine of a times cosine of b plus sine of b times cosine of a, and it's a plus because it's opposite trig functions. And it's the same plus, I guess. And so now I'm going to work on g of theta. So g of theta is sine of theta plus pi over 2. And so I'm going to write that in terms of the angle addition formula. So it's going to be equal to the sine of theta multiplied by the cosine of pi over 2. And cosine of pi over 2, that's 0. Plus sine of pi over 2, that's going to be 1, times cosine of theta. And if I, think about that, anything times 0 is going to be 0, and 1 times cosine theta, that's just going to be cosine theta. And we've actually seen evidence of this before, right, when we were graphing cosine for the first time. And so we now know that g of theta equals cosine theta. So if I'm trying to solve the equation f of theta equals g of theta, I'm just looking for the places on the unit circle where sine theta equals cosine theta, and I know where that happens, right? This is going to be a 45, 45, 90 triangle where either both of the legs are positive or both of the legs are negative. So it's going to be pi over 4 and 3 pi over 4. So I know that there are going to be two solutions on the interval 0 to 2 pi. Right, number 2 is talking about secant theta. Which of these could also define f? So which of these is an equivalent form for f? Okay, well, I know that secant theta is 1 over cosine theta, so I'm just going to choose answer choice B and move on. I guess what I will say is that, like, C and D, remember those are talking about inverse cosine and inverse sine, like arc sine and arc cosine, which we have talked about a little bit in this class, but not a whole lot. And those do mean something different. Those are going to give us the angle that corresponds to a given sine or cosine. Okay, this one I think is probably out of bounds because you don't necessarily know what inverse sine of negative 1/5 is. But if f of x equals sine x and the domain of f is 3 pi over 2 to 2 pi, which of these is the solution to f of x equals negative 1/5? All right, well, I'll just give you a preview of where we're going with this stuff. What I'll tell you is on the test, it's all halves, root 2 over 2's, root 3 over 2's, 1's and 0's and stuff like that. Okay, so if I'm thinking about the unit circle, and I usually try to draw the circle first, because it's probably not, that's pretty good. We're really only between 3 pi over 2 and 2 pi. That's the domain of f. And so I'm going to kind of like emphasize that part of the circle right here. And we're looking for where f of x sine x is equal to negative 1/5. Well, negative 1/5 is really not very far down there. I'll just say negative 0.2 right there. And so we're looking for this coordinate right here. Now, arc sine, inverse sine, that's going to give us the most obvious place on the unit circle where this happens. Now, what's most obvious we haven't really talked about yet, but it's going to be a negative value of theta, and is what this is going to return. So, like, you would think inverse sine of negative 1/5, that'll give you a negative theta value. But if we're between 3 pi over 2 and 2 pi, we're going to need to go around the circle one full time to get that, x coordinate that got us there. And so that's why it's going to be sine of, or inverse sine of negative 1/5 plus 2 pi. But you really don't know that yet, and there's not going to be anything like that on the test. Okay, oh, I like this one. So we've got f of theta equals g of theta on the interval 0 to 2 pi. So I'm just going to set these equal to each other. Cosecant theta equals sine theta. And, well, we don't know a whole lot about cosecant except to write it as 1 over sine theta. Okay. And now I'm going to multiply both sides by sine theta, and so that'll be 1 equaling sine theta times sine theta is going to be sine squared theta. And if sine squared theta equals 1, I could take the square root of both sides and get plus or minus 1 equaling sine of theta. And if I'm thinking about the circle and thinking about where sine is 1, that's going to be up here, negative 1 down there. So that'll be pi over 2 and 3 pi over 2 only. Okay. Function f is given by f of theta equals sine theta, using the fact that pi over 12 is able to be written as pi over 4 plus negative pi over 6. What's the value of f of pi over 12? Okay, so what we're really interested in is f of pi over 12 is sine of pi over 12. And I mentioned this in my classes. In my classes, we learned both the angle addition and subtraction formulas for sine and cosine. But, after thinking about it more, I decided that if I was going to teach this class again in the future, which I'm not sure if I will or not, I would probably only tell students to memorize the addition formula and then do this. Just think about negative pi over 6, because y'all are pretty good at drawing the reference triangle for a negative angle and knowing where that is. And so I'm going to do what they're suggesting, plus negative pi over 6, just to kind of give you an idea of what that would look like. Okay, and just like the other ones, I'm going to draw two reference triangles, one in blue, one in red. Let's see if I can get that to look a little nicer. And I'm going to write down the angle addition formula for sine. So sine of a plus b. Okay, sine is sine cosine. So sine a cosine b and sine b cosine a. Because these are opposite trig functions, I'll have the same plus or minus in the middle. And so I'll be interested in pi over 4. So that's root 2 over 2. This is root 2 over 2, and that's 1. And then I'll draw a reference triangle for negative pi over 6. Okay, that's a 30, 60, 90 triangle. It's going to have a short reference angle because it's pi over 6, so that'll be 1/2. Hypotenuse is 1, long leg is root 3 over 2, but the 1/2 will be negative because I'm down there in the fourth quadrant. All right, and so now I'm going to be able to go and say, all right, sine of A is going to be sine of red. Cosine of B will be the horizontal leg on the blue triangle, plus sine of blue is going to be negative 1/2 times cosine of red would be root 2 over 2. And so I'll have root 6 over 4 minus root 2 over 4, and there it is right there. Oh, this is nice. I wish I'd seen this one a little sooner. This one would have been a good test question. Beta is an angle in standard position, and sine of beta equals 0.8, and cosine of beta is 0.6. What's the value of cosine of 2 beta? Okay, if you know the double angle formula for cosine, you know that cosine of 2 theta is cosine squared theta minus sine squared theta. You could go in and just like do that. Cosine squared theta would be 0.6 squared minus sine squared theta would be 0.8 squared. And then that would give you answer choice C. But if you didn't know that, you would need to use the addition formula for cosine, which we have not talked about in this video, so I'm going to just go in and do that right now. Cosine of A plus B. All right, cosine is cosine, cosine, sine, sine. And because I've got the same trig functions attached to each other, I'm going to have the opposite plus or minus in the middle. And I'll say, all right, well, A and B are both equal to theta, so cosine of theta is going to be 0.6 times 0.6 minus sine of beta was 0.8, 0.8. Okay, and then you could get the same answer, using the angle addition formula. So really doesn't matter. I think it would be helpful to you to know the double angle formulas, but you can definitely get by without knowing them as long as you know the addition formulas. Okay, number 7 has got an equation. Just find the zeros. So this is a pretty typical equation for us to solve in this unit. We're going to have to apply a Pythagorean identity because I've got, in my original equation, I've got f of theta equals 0. So 2 cosine squared, 3 sine theta minus 3, that needs to equal 0. Okay, but I've got the cosine and the sine, so I need to substitute on one of those. Okay, what I know for sure is that cosine squared theta plus sine squared theta equals 1 for every theta. So I'm going to try to get rid of this cosine squared theta and write it entirely in terms of sine, and maybe I'll be able to factor. Okay, but you've seen me do this before. This is going to be 1 minus sine squared theta. We're going to make that substitution. 1 minus sine squared theta. It's getting doubled. We're going to add 3 sine theta and then subtract 3, and that will equal 0. So I've got negative 2 sine squared thetas. Okay, I had a 2, but I'm going to wait and subtract the 3 from that in a second. Plus 3 sine theta minus 1 equaling 0. And then I don't like how the leading coefficient is negative, so I'm going to multiply both sides of the equation by negative 1, and I'll get 2 sine squared theta minus 3 sine theta minus 1 equals 0, and hopefully this is the type of thing we'll be able to factor. And I'm going to take it off to the side and say 2t squared minus 3t minus 1 is equal to 0, and you know, we like to split the middle term here. I'm going to say 2 times negative 1 is negative 2, so I'm looking for numbers that multiply to negative 2 while adding to negative 3. That does not seem right. I did not multiply the negative 1 by negative 1. Okay, so that will be a lot better. Factors of 2 that add to negative 3 would be negative 2 and negative 1. All right, so 2t squared minus 2t minus another t plus the 1, that will equal 0. And I'm going to factor by grouping, and I'm going to factor out a 2t and be left with a t minus 1. So now I need to figure out how to get a t minus 1 out of the second two things. That would be by factoring a negative 1. Okay, so that would be t minus 1 times 2t minus 1 equaling 0. T is going to either equal 1, or maybe t would equal add 1 divided by 2. Alright, and t was standing for sine theta, so I'm going to say over here, alright, well, sine theta is equaling 1, or maybe sine theta is equaling a half. Okay, I'm going to think about, right, well, sine of theta equaling 1. That's going to be where my vertical displacement from the x-axis on the unit circle is positive 1. That's the most it could be. That's up at the very top. That's going to be pi over 2. So I'm down to b and c. And then sine theta equals a half. Okay, there's going to be 2 solutions to that. And switch up my color real quick and say, all right, sine of theta equals a half. That would be around there. So kind of big for the highlighter, but it'd be right here and there. So what I'm saying, the first stops, and that would be pi over 6 and 5 pi over 6, so I'm going to be choosing answer choice C. Okay, this next one's going to be a free response question. It's either going to give you some instructions, which basically boils down to show your work and simplify your answer. If you want to get the credit. So part A, functions g and h are given below. Rewrite g as an expression involving only one trigonometric function. Okay, h, same story. All right, well, maybe we can do that. All right, secant over cosecant. Well, secant is 1 over sine theta. Is 1 over cosine theta. That was secant. And then we're dividing by cosecant, which is 1 over sine theta. If we're dividing two fractions, we're going to keep the first one the same. Change the division to multiplication and flip the second one. So that'll be sine theta over 1, and that would give me sine theta over cosine theta, and we know that's tangent theta, and that is writing it as, nope, got a little ahead of myself there, sine theta over cosine theta, and that is tangent theta. So I rewrote it as an expression involving only one trig function. Okay, sine of 2x over cosine x. Oh, I like this one. I wish I'd thought of this one sooner. Oh well, I'm not very good at thinking of these. On a sine of 2x, we need to apply a double angle formula. And, we already did it once. I developed it using the addition formula. If you don't know the double angle formula, this one's going to take you longer, and you would have to develop a formula for sine of 2x by doing the angle addition on sine of x plus x. But I know that sine of 2x is 2 times sine x times cosine x, so I'm just going to use that. It's that double angle identity, and I'm dividing by cosine x, and so I'm looking for an expression with one trig function, and that will happen when I cancel off the cosine x's. So this is equal to 2 sine x, but not for every x. That would be only, where But I guess that would be, because I can't have where cosine was 0, but h wasn't going to be defined where cosine was 0 anyway, so, okay, so yeah, it's not like I've lost any part of my domain or anything. And that's an expression involving only one trig function. Right, part B, j and k are given below. Inverse sine of 2x. Okay, yeah, I think we probably took number 2 off of there, because you don't know how to solve those equations quite yet. Although I think you probably have a pretty good idea of how. So j of x equals negative root 3 over 2 on 0 to 2 pi. So cosine x equals negative square root of 3 divided by 2. This is just an old-fashioned trig equation. But we need to be ready for those two. Okay, so cosine is negative root 3 over 2. Negative root 3 over 2 is really far over on the circle. That's like almost all the way to the edge. It's the last stop before the farthest we can go. So that would be right here and right there. And that's going to be 5 pi over 6. And this one will be 7 pi over 6. So I would say, you know, x equals 5 pi divided by 6, and also 7 pi over 6. We're looking on just the interval 0 to 2 pi, so I'm happy. I'm sure I'm not missing anything here. Yeah, that one was really nice. Right, in part C, we've got a nice little multiplier here. Cosine of 3x equals a half. Okay, we like those. So cosine 3x equals 1 half. Okay, and just to remind you, like, what we were either doing explicitly off to the side or just thinking about it like this in our mind is we were thinking, all right, let theta equal 3x. And we're really interested in where cosine of theta is going to be equal to 1 half. And that's something we know how to do on the unit circle. Okay, so cosine equals positive 1 half. That would be the first stops after 0. So it'll be up here at what looks like pi over 3 and negative pi over 3. Okay, you could call it 5 pi over 3 if you want, but to me it looks more like negative pi over 3. Okay, so that's the values of theta that make cosine theta equal to 1 half, but theta equals 3x. So I'm going to say 3x is either equal to pi over 3 or any angle coterminal to pi over 3, or maybe 3x is equal to negative pi over 3 or any angle that's coterminal to negative pi over 3. So 2 pi n, where n is some integer. And I'm going to divide both sides of both equations by 3, and that will just require me to divide everything by 3. So 2 pi over 3n, and also negative pi over 9 plus 2 pi over 3n, where n is any integer. Okay, we were talking recently about, because there's going to be a question kind of like this on the AP exam, on the free response. We're talking about, do we think that the students need to write where n is an integer? And I am really not sure. Something tells me maybe no, but if it was my AP exam and it decided whether I was going to get credit for pre-cal or not, I would definitely write where n is an integer, like when it really counted. Alright, now we're going to move on and do some problems that were from the notes book that I think would be particularly useful to you, on the upcoming test. So the graph of the sinusoidal function f is shown above. Of the following, which of these is the greatest? Okay, so I'm going to go in and kind of measure each of these lengths. The length of the interval for which f of x is less than or equal to 1. Well, f of x is only equal to 1 right there. So that length of that interval would be 0. So that probably is not going to be it's not going to be the greatest. The length of the interval for which f of x is greater than or equal to 5. Okay, well that would be here to there, right? Because I'm greater than or equal to that 5. And so the width of this interval, it looks like it's starting at about a half, so it would be about 1, 2, 3, 4. So I'd say that's about 4. The length of the interval for which f of x is less than or equal to 2. I'm just going to do the same thing. F of x is equal to 2 right here and right there, and less than down here. So I'm thinking, you know, from here, that's about 1, 2. It's less than 3. Okay, that's what I'll say, less than 3. And then the length, sum of the lengths of the intervals for which f of x is between 3 and 4. Okay, well, f of x is between 3 and 4 here and also there. And so what I'd say is that the width of these intervals, it's less than 2, because the width of each of those yellow pieces is less than 1. So I'm going to say less than 2, which means that the greatest of these would be answer choice B, the one that had length about 4. Okay, there's just a intersection point problem, so I'm not sure why I put this one on here, but it wouldn't be bad practice. So we're going to set these two things equal to each other. We're looking on the interval 0 to 2 pi, so 3 cosecant x. I'm going to subtract 5 from both sides, divide both sides by 3. Negative 6 divided by 3 would be negative 2. I'm not really an expert on cosecant, so I'm going to write that in terms of sine. Cosecant is 1 over sine, so if cosecant is negative 2, sine of x will be negative 1/2. And then I'm going to say, all right, well, sine x equals negative 1/2. We'll be able to find that on the unit circle. 1/2, that's not very far, and sine is like kind of a vertical displacement from the x-axis. So I'm just going to go down a little bit to the first places, and that would be 7 pi over 6 and 11 pi divided by 6. So those will be my solutions. I'll say x equals 7 pi divided by 6 and also 11 pi over 6. Okay, and now we'll do one where we're going to factor, and that'll be good too. So 2 cosine squared theta equals negative cosine theta. I guess I just rewrote what they'd already given me. That didn't really do anything, but that's all right. 2 cosine squared theta. I'm going to add the cosine theta to both sides. Because if I was to divide both sides by cosine theta, I would definitely be losing solutions in this case. Because it's like, what if I just divided both sides by 0? We'd end up with the part where we'd get factoring out a cosine theta. We'd have 2 cosine theta plus 1. Okay, we'd still have those solutions, but we wouldn't have these other solutions. So either cosine is 0, or maybe cosine theta is subtract 1 divided by 2, negative 1/2. Okay, that's not going to be a suitable x-axis. Be a little better. That'll do. Okay, so I'm thinking cosine theta equals 0. Cosine theta equals 0 when there's no displacement from the y-axis. That would be up here and down there. It would be theta equals pi over 2 and 3 pi over 2. Because we're only looking on 0 to 2 pi. Now, you think about where cosine is negative 1/2, and that's not very far over to like the first stop on the unit circle to the left of the y-axis. So that would be 2 pi over 3. And also 4 pi over 3. Those would be my solutions on the interval 0 to 2 pi. Alright, now a little bit more double angle formula work. So which of these is equivalent to g of theta equals 9 sine of 2 theta? Well, sine of 2 theta is equal to 2 sine theta cosine theta. Okay, so if I had 9 times sine of 2 theta, I could just multiply both sides by 9, and I would get 18. Okay, I really think that it would help you to know these formulas, because these are two multiple choice questions that are very similar to two that you will encounter on the test. Okay, on number 10, okay, cosine of 2x, we need to know the double angle formula for cosine. That's cosine of 2x is equal to cosine squared x minus sine squared x. And then if I was going to multiply both sides of this equation by 3, I could say 3 of those is going to be 3 of these, but then it won't look exactly right, so I'm going to need to do another substitution. So I'm going to say this is equal to 3 cosine squared x minus 3 sine squared x, but that's not what I've got. Okay, so I'm going to need to remember that off to the side, maybe, oops, cosine squared x plus sine squared x is equal to 1. So maybe I could get rid of, okay, well, I'm looking at what's already negative, and that's the sine squared. So I think I might just try to get rid of the cosine squared, because I'm thinking c. C looks the best to me right now. So I've got cosine squared x equals 1 minus sine squared x. So 3 times 1 minus sine squared x, and then I'm subtracting 3 more sine squared x's, and that would be 3 minus 3 sine squared x minus 3 more is going to be, that's where I'm going to get 3 minus 6 sine squared x. I'm going to choose that and move on. Now I think, oh nope, there's still more. So terminal ray of angle theta 1 in the standard position intersects the unit circle at A and B. Alright, so I'm going to just draw theta 1 real quick. Theta 1 looks like that. And the intersection point they said was A and B. Okay, and so what I know for sure is that A equals cosine of theta 1 and B equals sine of theta 1. Then I'm going to draw another diagram. This one's going to have to be a little smaller, I think. But I draw theta 2 to be, about the same, but, noticeably different. Okay, so there it is, and I've got this intersection point with the unit circle, which they said was C and D. So I'm going to write down, okay, I know C is cosine of theta 2, and D is sine of theta 2. Because that's really what those coordinates of the intersection point between the terminal ray of the angle and the unit circle are cosine and sine. So they're asking me about the coordinates of the point at which the terminal ray of angle theta 1 plus theta 2. Okay, so I'm going to need to use, if I've got these together, and I'm definitely run out of room here, but that's all right. Okay, if theta 1 plus theta 2, it looks like it's probably going to be a little obtuse. So I'm going to draw it like that. And I don't know if that's actually... I'm just going to call those coordinates x and y. And so x is going to be cosine of theta 1 plus theta 2, and y is going to be sine of that. And, oh man, right, we've got a formula for cosine of an addition. That's going to be equal to cosine theta 1 cosine theta 2 sine theta 1 sine theta 2. And because these were the same trig function, it's going to be the opposite, plus or minus. Alright, so cosine theta 1, that's A, and cosine of theta 2 is C, minus sine of theta 1 is B, sine of theta 2 was D. And then for sine of theta 1 plus theta 2, I'm really out of room here. That's going to be sine cosine. Sine theta 1 cosine theta 2. Sine theta 2 cosine theta 1. You can't even see that. Well, that's not going to help. There we go. And since it's the opposite sign, it will be the same, plus or minus in the middle. Alright, so sine of theta 1, that was B, cosine of theta 2 was C, so BC plus sine of theta 2 is D, cosine of theta 1 is A. Alright, there we go. We've written the coordinates x and y in terms of A, B, C, and D. Alright. Okay, yeah, this is a good one. This one will be relevant to you. This is much better as a multiple choice question, but I did the best I could on this one. So, solutions to the equation f of x equals a half. So, sine of x plus pi over 3 equals 1/2. All right, now we need to remember the angle addition formula for sine. Sine of a plus b. Sine is sine, cosine. So sine a, cosine b, sine b, cosine a. And since these are opposite trig functions, I've got the same plus or minus in the middle. All right, and so now I'm going to need to know about sine of pi over 3 and cosine of pi over 3. Okay, because pi over 3 is going to be b in this picture. Okay, that'll get the job done. That's 1/2 root 3 over 2 and 1, and that's for pi over 3 right there. So I'm going to be saying, all right, sine of x, well, I shouldn't say equals like that. Sine of x plus pi over 3, sine of a plus b, sine of x multiplied by cosine of pi over 3 plus sine of pi over 3 multiplied by cosine of x, that's still going to equal 1/2. Okay, but they're interested in where this equals 1, so I'm going to multiply both sides of the equation by 2. And then I'll have 2 sine x times 1/2 plus 2 times root 3 over 2 cosine x. That's equaling 2 times 1/2, which is going to equal 1, which is like it's supposed to. Okay, so I will see, all right, a is going to be 2 times 1/2, a equals 1. B is going to be that 2 times root 3 over 2, so b will equal the square root of 3, and these will be the values of a and b that make the equation true. Alright, now I'm on to the last page, and how many solutions does the equation have on the interval 0 to 2 pi? So cosine of 3x is equal to positive root 2 over 2. Okay, we've already got it down to trig function equals number, so we can just think about, okay, where on the unit circle is cosine going to be root 2 over 2? Root 2 over 2 is in the middle, and cosine is positive, so I'm to the right of the y-axis. It's going to be here and there. So it'll be at pi over 4, and what I would think of as negative pi over 4, but maybe since we're looking for 0 to 2 pi, that would be 7 pi over 4. Okay, and so that means that 3x equals pi over 4, and also 3x equaling 7 pi over 4. Okay. And then if I was to divide by 3, I'd get x equals pi over 12. And also x equals 7 pi over 12. But these aren't even all the way to 1 pi, and I'm thinking there's possibly more solutions here. Okay, so I'm going to be looking for maybe the next time around the unit circle. I'm not going to add plus 2 pi in, I'm just going to add 2 pi twice, okay, because if it's 3x, I do need to look around the unit circle 3 times. So adding 2 pi would be like adding 8 pi over 4, so it would be 9 pi over 4. And if I divided that by 3, I'd have 9 pi over 12. And then the third time around the unit circle, I'd add 8 more pi, so that would be 17 pi over 4. And if I divided that by 3, this would be 17 pi divided by 12, which is less than 24 pi over 12. So, okay, I've got 3 solutions from that one. I'm thinking probably 6, but I should make sure. Add 8 pi over 4, and add another 8 pi over 4. Yeah, and then when I divide by 3, I'll get these numbers divided by 12, 15 pi over 12, and 23 pi divided by 12. So I'm going to have 3 over here, 3 over there. These are all between 0 and 2 pi, so that's 6 solutions. Okay, what I was going to say, oh yeah, and just really emphasizing that if I have this 3x here, and I'm looking on the interval 0 to 2 pi, I need to look 3 times through the circle for solutions. Right, and this one is talking about how many solutions on the interval 0 to 3.5. This is an interesting one. So sine of 2 pi x equals negative 1/2. Well, we can figure out where sine is negative 1/2 and just kind of go from there. Okay, so sine is negative 1/2, not very far down below the x-axis, right here at 7 pi over 6 and 11 pi over 6. So 2 pi x, maybe I'll do this one with the actual general solution. 7 pi over 6 plus 2 pi n, where n is any integer. And then also 2 pi x could equal 11 pi over 6 plus 2 pi n, where n was any integer. And then I'll divide both sides of both equations by 2 pi, and so I'll lose the pi and then throw a 2 in the denominator, so 7 over 12 plus 1n, and then x is going to equal 11 over 12 plus 1n, where n is any integer. All right, so I've got 7 over 12. 7 over 12 plus 1 would be, okay, well, just 1 and 7/12 is 19 over 12. And then the next one would be adding 12 to that, to 3.5. I think I might have messed this equation up a little bit, but that's all right. I might have been going for like 1.5 or 2.5. Maybe 2.5 was what I needed. Anyway, 7/12, 19 over 12. Okay, I would be adding 12 more over 12, and that would be 2 and 7/12. This one's going to be 6 also. Hold on. Let me change this. I see what I was going for. I think I needed to either make that sine of pi x or 1.75 there. All right, so 1.75 would be 12, and then 3/4 of 12 would be 9, so it'd be 21 over 12. All right, so I'm good with that one. It's just the next one, if I added 12 more pi, that would be 31 over 12. That's outside of the interval 0 to 1.75 because it's bigger than 2. All right, so x equals 11 over 12. That's definitely between 0 and 1.75. If I add 1 to that, that would be 23 over 12. So you mean plus there. And then that's almost 2, and that's bigger than 1.75, so I'm going to cross that one off as well, and I'm going to get 3 solutions over there. Okay, I wanted an odd number of solutions for this example. All right, the last one we've got here is cosine of x plus pi over 3, and g of x equals f of x plus pi, or root 2 over 2. So I'm going to write a formula for g of x, because they're looking for the zeros of g, not the zeros of f. So g of x is f of x plus pi over 3, and that's equal to, or no, plus root 2 over 2. F of x plus root 2 over 2. All right, now if I want g of x to equal 0, that's just going to happen when the cosine of x plus pi over 3 is equal to negative root 2 over 2. And I'm sure you could go and apply the angle addition formula, but this is a situation where that would take you farther away from where you wanted to go. I want to solve this equation. I want to figure out the values that make the equation true, and I've got trig function equals number, so all the way back to kind of where we started. Now I'm ready to go to the circle. So I'm going to say go to the circle and think about where cosine is negative root 2 over 2. And root 2 over 2 corresponds to pi over 4s. And cosine is negative, places where x is negative, so that'll be over here and down there. It's looking like 3 pi divided by 4 and 5 pi divided by 4. And so now, okay, that's what x plus pi over 3 is going to equal. These spots right here. So x plus pi over 3 equals 3 pi over 4. And x plus pi over 3 equals 5 pi over 4. Oh, I didn't even look. It said 0 to pi. Okay, but had I looked at that too early, I might have been like, oh, I'm not interested in 5 pi over 4 because it's beyond pi. But if I subtract a pi over 3 from it, it is going to get pulled back into my interval of interest. So I'm going to subtract pi over 3. maybe I'll turn these into twelfths. So that'll be 9 pi over 12 minus 4 pi over 12 when I subtract pi over 3. And that would be 5 pi over 12. Then this one would be 5 pi over 4 is multiplied by 3 over 3, 15 pi over 12 minus pi over 3 would be also, again, 4 pi over 12. So 15 minus 4 is going to be 11 pi over 12, and both of these are between 0 and pi, so these are going to be my solutions. And yep, that's going to be all of the problems on this review set, so that's going to be all for this video. Thanks for watching.